So in this video, I want to take a look at this solid state music IO-4 card. It's got two serial ports, serial A and serial B, and two parallel I/O ports. We've got input 8-bit port B and output port B, and then output port A and input port A. The parallel ports are implemented with these 74 S412s. The 8212 is also the same part. So what we've got on the card are a couple of AY5 1013 UARTs. These UARTs are configured via the dip switches here. So this dip switch and this dip switch serve the same function, one for each UART. And what this dip switch does is set the number of bits, the number of stop bits, the parity, etc. And I believe I have this set correctly to give me an 8N1 RS-232 configuration. So 8 bits, no parity, 1 stop bit. And I've done the same thing for both ports. How I received the card had a different set of straps in here on these two jumpers. These jumpers are used to take the various status bits. So this UART actually has hardwired pins on the inputs to set bit width and that kind of stuff. And then hardwired pins as outputs for, you know, there's a byte weighting in the buffer, overflow, those kinds of things. And those outputs are taken to this header here. And then what you can do from here is strap those bits where you want them to be. We'll look at this a little closer in another photo, but you can strap, say there's a byte weighting in the receive buffer to the particular bit you want on the bus, data 0 to data 8, for your particular CPM system or whatever to read. And this way you can kind of make this look like a universal UART. You can make the UART appear to be almost any other kind of UART by remapping bits. You can also swap this 74367 here and here with, I believe, a 366 that doesn't invert the bits. So you can either get active high or active low signals. So it's actually an interesting card for configuration. The baud rate is hard strapped down here. In this case, I have receive and transmit for both A and B set to 9600 baud down here. That's just hardwired through that little loop of wire. It's got a couple of 14-pin dip headers for output. So I've got the signal grounds here, and one of these leads is transmit and the other is receive. I don't remember. And I've configured it again for 2 ports. I have powered this card up long enough to check output voltages. So we've got plus 12. There's a minus 12 volt regulator back here, and a plus 5 and a plus 5 regulator that are split kind of for different halves of the board. Down here we set the port or ports for the serial, the UARTs to live on. And in this case, I've got A7 high and all the other addresses low, and that's mapping the board to port 128 decimal. And so what we end up with here for serial A is port 128 is the status bits here, port 129 is the data, so receiver transmit data, 130 is the status for this guy, and 131 is the data for this guy. And that status data is the same order that the MITS serial card in the original Altair 8800, or Altair, I always say it wrong, 8800 used. So this should be pretty close to emulating, I think, that card. I just need to change the ports down here. As another note, there's another port decoder here. It's for the parallel ports. Right now I've just got these all set to 1s. And that's mapping these on port 254 and 255, I believe, again decimal. So the intent in the video here is to actually power this card up, jump into BASIC as I often do, and start spitting characters out to these UARTs and just see if I can actually get those characters back. So before we move on and do that, this is the drawing I did. Well, this drawing comes out of the manual, but then I modified it to show the connectors, the pin out of the serial connectors. So we've got the grounds here on pin 7 and 8, which would be 7 and 8 here and here. And then the RS-232 out and in on pins 1 and 11. These pinouts for these guys are both the same. We've got these jumpers we looked at where I've got the crossed wires that are taking, I believe that's transmit is ready to transmit a byte to data 7, and I think this one's a received character is ready to bit 0. I think that's correct. And then we talked about the receive and transmit for the 2 ports jump down to 96K or 9.6K baud. And then there was the 2 dip switches we looked at, and this also captured for me the dip switch settings. So parity is actually off. We've got no parity set down here by that switch being off, which this gets ignored. By these 2 switches being off, we set 8-bit parity. We set 1 stop bit. And then this switch down here sets whether the status is first or the data is first on those ports. And this is what's set in our configuration. UART-A status to be on port 128, 129, and then UART-B status on 130 and 131. Does that really cover the photos? I guess it does. Luckily online I found a manual for the card, and there's all kinds of good information in here. Assembly manual, etc. So again, if you have one of these cards, this manual was invaluable in my getting this figured out. I actually have a second card that's identical, that's in a lot rougher shape than the one I'm using, that's missing heat sinks, a couple of parts, etc. It could be fully restored or make a good parts card for the one I've got. But with this introduction done, I think the next step is to jump in, boot the IMSI up, and see if we can make that card do anything. So we've got the IO-4 card in the machine. We're set up here to be able to boot the CPM. I've got a couple of serial cables coming off the machine back to a couple of serial ports on my main PC. We'll take a look at that in a second. So let's go ahead and get the machine started up. So let me apply power. Looks like the machine came up. Get a look at the front panel here. On the inside, I'll go ahead and do a reset. Set to address FF00. Let's examine that address. I'm going to turn the floppy drives on here and close the door on the CPM floppy. And we'll go ahead and run that address. And we can hear that the machine has booted, so that's really nice. So here on the computer screen, I've got COM1 here, and this is set to the, what's the card called? The 882 SIO-JP card. That's a modern kind of reproduction multi-purpose card that I use to get the machine up and running. And then I have a couple Teraterm connections here on COM2 and COM3, and these two are going off to the 2 ports on that solid-state music card. And so what I want to do is just spit characters out to these and see if they actually do anything. The setup on these, we can look at the setup quick. Both of these set 9600 baud, 8-bit, no parity, and 1 stop bit, just like the straps on the card are set to. So hopefully we'll have some luck here. So let's get into basic. Oops. M basic. Wow, it's going to be that day. We'll get M basic loaded. And with M basic loaded, I can turn off the floppy drives just to remove some of the background noise. So let's do line 10 for data equals a space to character 127, 15 out. So remember, 128 was the status, 129 should be the data on UART-A, DT, 20, next, DT. And what I'm hoping is this should spit out to this UART right here. If everything's wired right and I've done this right, awesome. So we've got UART-A hooked up. The bits width and everything are correct. So reading the manual and planning, as I always do, you know, with the dip switches and stuff, has helped. So now let's look at the other UART, see if we get lucky. Change to a 3, change to a 1, and hopefully this will spit out to this session here. Oops, it would help if I And it does. Oh, that's an excellent sign. So I've got what appear to be at least 2 working UARTs for outputting data. So 15, 16, out 129, DT. 25, go to line 10, and this should just cycle here, spitting out characters to both UARTs. So that's a really good sign. This doesn't mean I've got the status bits on ports 128 and 30 set correctly. That's more stuff to play with, but this was step 1, is I've got the card strapped correctly. It's at 9600 baud. Like I said, the bit width, parity, etc. match. That's a really good sign, and this does say that card is functional, at least for the serial ports. So, shoot, with that said, not a whole lot to troubleshoot here. We got lucky. Well, I say I got lucky. I planned ahead. I read the manual. I created this graphic here to guide me on how to jumper things. And so far, so good. So, I guess I'll wrap this up. And for the first test of the solid-state music IO-4 card, we're successful.